Good morning, physical science. Welcome to Monday, November the 30th. First full week of remote, and hopefully the last full week, as we are due to come back next Monday, December 7th, for a Harbor Day for you history buffs. This week, we're going to be wrapping up this whole idea of chemical bonds. We've been talking a lot about ionic bonds. Remember that? Metal and a non-metal. Electrons are taken or transferred. The bullies, the non-metals, picking on the wimps, the metals. And so there was a lot of taking of electrons. We're not going to take any electrons. Now we're going to be talking about covalent bonds. This prefix co means to share, like a co-captain of a football team, co-captains on the swim team. They share the duties of the captain. Well, valent refers to valence electrons. So you can kind of see that covalent involves a sharing of the outer valence electrons. So covalent bonds are going to be between elements that are non-metals. There's no metals involved here. Remember, non-metals are bullies. They have the higher ability to take electrons. Well, if you have two bullies together, like two chlorines, well, who's going to win that tug of war? Neither one. I've got a chlorine atom with a high ability to take electrons, and it runs into another chlorine atom with a high ability to take electrons. They're going to square off, and neither one can take from the other. So in the end, they're going to share the electrons. So they're going to share these electrons. But let's talk about exactly what that means. This chlorine has 7 valence electrons. It's a halogen. Use your periodic table. You can verify. This chlorine, well, imagine that. It's a halogen as well. It's a chlorine. They're the same. It has 7 valence electrons. So what they're going to end up doing is these outer 2 valence electrons right here, they're going to share that pair. Now this chlorine, for example, has 2, 4, 6, 8 valence electrons. It's sharing the one from the other chlorine. This chlorine atom, in turn, has 2, 4, 6, and it's sharing this pair. So this is a single covalent bond. Single meaning they're sharing one pair of electrons. All right. Now, there are other situations that we can take a look at as well. An example here would be HF, hydrogen fluoride. Hydrogen has 1 valence electron. We show that right here with this electron dot diagram. Fluorine, as you already know, has 7 valence electrons. Well, covalently speaking, between 2 nonmetals, this is a bond made in chemical heaven. Because the hydrogen is going to share its 1 valence electron with the fluorine, and it's going to share. So what happens now is hydrogen has 2 valence electrons. Well, that gives it the same configuration as helium, which is a noble gas, which is stable, inert, as a stable octet. So hydrogen's happy. Fluorine is going to share that 1 pair, and now it has 8. And it's just like the noble gas neon, closest to it. Remember, they're trying to be like the noble gases. Keeping in mind that covalent bonds are very different than ionic bonds. Covalent bonds only occur between elements that are non-metals, and they're going to involve a sharing of electrons. On your Schoology account for today, you have a couple items to attend to, so good luck with that. I'll be in class till the end of the period. If you need me, jump back on your Google Meet. Otherwise, have a great day and happy Monday.